Hello.
Hello.
Yes, hello. Can you hear me?
Yes.
Okay. So, Leo, I allow you to share your screen?
There's two exercises from last lesson.
Yes, yes, exactly. So, how was it? Was it difficult?
I know it was fine.
Okay. So, do you feel, Leo, that your level at pseudocode and Java is the same?
Yeah, I think it's similar.
Okay. But do you have a preference?
Uh, yeah, Java it feels more natural for me personally.
Yeah, yeah, okay, that's logic. And do you know why people would decide to use a pseudocode at initial stages of software design?
Well, it's a way to, I guess, it's a way to like prototype it before like actually creating it.
Okay, that's a good answer. And also, it's another way if we want to communicate with other programmers who really are not going to write every part of the system in the same language. So you could be there could be a system that is written in different programming language, and the only way to communicate the system details or the software design details, so that everybody on the table can understand that it will be language non-specific. I mean non-specific programming language details. So that will be in the pseudocode. Okay. So now share with me. Okay. Interesting. Yeah. 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 Okay. Wait, which answer is that?
And that's B that's the answer for B. The sum of the divisors.
This is a sum. Okay. Uh-huh. But then, Leo, can you check again, please, the question? Can we check it we both together so that we are on the same page? The requirement was to sum proper divisor. Am I right?
Yes.
Here. Yeah. So your loop here, uh, you're looping from what to what? Sorry, let me
Oh,
see.
1 to n.
1 to n. Okay. And did you check that if you pass 16, it should return 15? So now what you are looping through at the moment, you are looping from 1 to n, and n is 16. So you are looping from 1, I mean from your code, if I look at your code. And um, so now think with me. If I'm looping from 1 to 16 and I say n mod count, right? That's what you're writing. So are you able to do some kind of an analysis for me? Like, okay, now forget about from 1 until 7. Now talk to me. So from when the count is from 1 to 7, okay, fine. That's no big deal. Now I want you to sync with me. If count equal 8, okay? So go through with me. So n mod count equal 0 or not?
No, it wouldn't.
So 16 mod 0, sorry, 16 mod 8 equal
Oh yeah,
what?
that would be 0.
That would be 0, right? So okay,
Yes.
and so n is 16 in this in the current examples that he provided to us. So now
Yes.
you go into the count now become 9, right? Am I right? After we have it 8, it will be incremented to become 9 because you are okay. Yeah, I understand. So you put it 15 here. Okay, I accept that. But think with me. If the count is 9, and then I would say 16 mod 9 equals 0 or not?
No, it would be 7.
Okay, okay, that's good. So it is not going to be this will when it will not be summed, right?
Yes.
Yes, but then if you talk about when the count equal 10, so 16 mod 10 equal
6.
good. So it will also not be counted, right? So put 11, 16 mod 11.
5.
Okay, now we run forward. 16 mod 15.
1.
1. It will not be counted, right? Okay.
Yes.
And 16 mod 16. No, you already put n minus 1. So what I want to say is that starting from count equal 9 until you reach count count equal 15 or even 16, you are actually not counting. Am I right?
Yes.
So does it mean that actually you should be somehow, possibly you can say n divided by 2
Oh, yeah.
or n div 2? You know what the meaning div, right?
Yeah.
What does it mean? Integer division.
Yeah, integrated division. So,
So this is, I mean,
yeah.
you can do it
Returns an
this way.
integer value. Yeah.
Yes. Okay. Yes. Perfect. So what I want to say is that since from 9 to uh, the perfect answer is that since from 9 to 15 or 16 is actually not counted, and he already mentioned to you, so it is more proper. And I mean, the ideal answer is to say not n minus 1, it's to n divided div 2. Okay. Yeah. Okay. And other than that, it's excellent. Um, but just be aware that this can make you lose maybe half of the mark, or maybe if the examiner is too stingy, then he might uh, deduct more. So, but then let us go back here. Requirement 1A, please. This slightly more tricky. You have
Which
seen
one?
the part A. So part A of that question was, let me see here. Okay, so part A said that we have, it actually described the divisors of 10, and he asks you to construct a logic expression that evaluates to true if X is a proper. Are we looking into the same page?
In the website, in the document, I got B, but for A, I only got the answers and not the question itself.
Oh, really? Oh, no.
Yes.
Okay. Okay, my bad. That's bad from me. Okay. Let me confirm that so that I okay. Okay. Yeah. That's a mistake from my side. Okay. So and but you understand it.
Yes.
Okay. So now show me the Java. Okay, can you go down with the code and share with me? Okay. Interesting. Okay, that's good. Yeah. Okay, we are good to go. So yeah, you can off your share and let me. So Leo, are you able to tell me if we have a company, this is an exam question, so if we have a company that is prototyping as an approach for a software development process, and we would like to know one advantage of prototyping and one situation in which the use of prototyping is not the best approach. So do you know what is prototyping first?
Yes.
And it is?
So prototyping is when you create like an early or like I guess it's kind of like a rough draft in order to like test aspects of a system before actually creating it.
Yes, an excellent answer. And what is the advantage?
Uh, it lets you plan out or map out potential issues before actually spending resources on creating the actual system.
Yes, and not only that, typically, if you are building a system that is complex enough and you have many programmers, um, if you have many programmers that is going to develop the system together, and even the owner of the system or even the big management, sometimes they imagine things that is not real, and to be able to make them visualize, I mean, and typically management assumes things uh, that should be moving in certain direction, but in reality the programmers are the people who are doing things on the ground and know that things might be look different than what was assumed by the top management, for example, or even the customer. So typically they try to visualize the software, so they either draw the screens or even they try to um, um, create maybe design only the UI, GUI, and share it with the customers and try to maybe put some important, only the top important features and for the customer or even for the management to really see what is it on the ground when it is executed. And from there, they are able to say, okay, there is a risk, or they can continue or not continue, and so on. So tell me then now one situation in which a prototype is not the best approach.
Uh, if there's a stricter time limitation, then there might not be enough time to create a prototype and the system itself.
Mm, well, I can't say that this is a perfect answer. Um, Typically, even if you have a tight deadline, if you don't try to design something first or even create a prototype, actually that will be a catastrophe at the end. Even if you have a tight deadline, one of the things that can prevent you really from making a prototype, or really it's not so important, is actually that. Um, you're creating a software that is that you as a programmer will be the only user for it. Okay. Another thing is that you have no customer, you have no end user. It will be maybe end user that is internal to the company. um, so that can be a situation where you actually don't create a prototype. Another way that prevents you from creating prototype, if you are creating a prototype for a lethal system, something related to nuclear or even surgical things on the medical side. So that is something can prevent you from creating a prototype because somehow is dangerous. But most of the time, creating prototype is actually important, especially if you're dealing with the end user. Typically, if you become a programmer at certain time, you will always deal with people who don't really understand what is the software. They don't. This is something that you cannot touch it, so they will never understand what it can do. Some people, some end users you will deal with, will always imagine that software can do everything and can cover or recover from any problem or even can solve any problem. And this is not true. So sometimes it's practical to let the end user visualize actually what you're going to build for him and what is the limitation. Okay. Yep. Okay. Now let us talk about pixels. Do you know what is a pixel is?
Yes.
Okay, what is it?
Pixel is the it's like the building blocks of like a digital image.
Okay. So it means that images are built out from pixels. Am I right?
Digital images, yes.
Okay. And why actually and what is the color depth? Did you hear about this term before? Color?
Color depth?
Uh-huh.
Yes, I've heard of the term before.
And what is that?
Well, I don't know the exact definition, but I've heard it like mentioned in relation to like bits, like bit depth.
Okay. And that's interesting. Okay. So good. I will explain that term now. Each pixel on a computer screen has three colors, three color values associated with it: red, green, and blue. The range for each of the three colors ranges from 0 to 255. Color values can be represented in hexadecimal. For example, the color blue can be represented in hexadecimal, and this is the value. State the binary representation of the color blue. Are you able to write the binary representation of that hexadecimal? Or you can
That
just
would
tell it.
be
Uh-huh. So 0 translate to what? And F translate to what? And I think
F
other than
translates
that is
to
enough. Uh-huh. Again?
F translates to 15, and 0 translates to a 0.
Yes, but then I understand it translates to 15, but he asked for the binary representation. So this single zero from here translate to how many zeros? So each two from those in hexadecimal represent what?
Byte,
Byte. Am I right? So each
yes,
one of those, it means that they are four zeros. Am I right?
yes.
And each F corresponds to
1111.
excellent. So by doing so, you are able to fill in the zeros and one to put the binary representation, right?
Yes.
Okay, perfect. Now state the number of colors that can be represented in each pixel on the computer screen. So state the number of colors that can be represented in each pixel on a
Uh,
computer screen.
256 cubed.
Excellent. Excellent. So I think that is clear to you. Let me see here. Um, so actually, the color depth is, let me get another. I didn't put too much explanation here. Um, So in short, color depths actually represent how many possible colors that you have for every pixel. And if we combine the RGB, which is a red and green and blue, each one of those have 2 to the power of 8, which correspond to 256. So which means that we have 256 for each color. Okay, so it means that we have 256 and 256 here. This is for blue, this is for green, and this is for red. So this information, you already have it. Are you aware of that? Is that clear to you?
Yes.
And okay, perfect. Let me see. Okay. Okay. Explain how increasing the size of a central processing unit, CPU cache, improves the performance of a computer. So how the cache actually affects the performance of the computer?
Well, the cache is what stores the frequently accessed data, which takes less time than accessing the RAM. So increasing the size of the cache would decrease the amount of time taken to process due to the decreased time taken to access a lot of the data.
That is excellent. And you know the difference between different cache types? How many cache types do we have?
I'm not sure.
So we have here L1, L2, and L3. And recently we start to have L4. And do you know? Okay, I assume you don't know because you are not aware of them. But can you guess which of those caches actually are in the inside the processor?
One.
Okay. So do you know how many cores? Do you know what's the meaning of a core inside the processor?
Yes, if it has more cores, then it's able to run more processes simultaneously as well.
Okay. So typically we can, I mean, recently we have up to, I believe, 9 cores, if I'm not mistaken. And so typical computer might, in this example, you can see 4 cores on the processor, right? So this is a processor chip, and this is the 4 cores inside the processor. So let me share with you a clearer portion here. So that image actually can explain to you that if we have L3, then it is shared among all the 4 cores, and it still can lie on the processor chip, and the processor chip have all the 4 cores. L1 and L2 will be for every core, okay? And then this L3 will be shared among all of them. Is that clear?
Yes.
Okay, so now you know that how many types of cache and where they are located?
Yeah.
Okay. Okay. Let me try to understand. So if we have a cache, it means that we are able to fetch data faster from the RAM. Does it mean like that? Or it means that we don't take too many cycles to bring the data from the RAM? Or what actually does it really mean?
It means that the amount of cycles is decreased.
Okay. Okay. So when I'm trying to execute a command or an instruction inside the processor, um, do I need to fetch all the instruction at once, or how? How
When
many
executing a
instructions?
process.
How many instructions the processors are able to run at one time?
Oh, well, it depends on the amount of cores.
Excellent answer. Okay. Okay. Tell me what is meant by a virtual machine.
A virtual machine is like a emulation of a computer system.
Okay. A detailed answer would be see. There is many types of virtual machines, and you can there is three of those that you are able to give an example with. So one of the usage of virtual machine that you have a computer software and you have Windows, for example, here, okay, and then it come to your attention or your need as a programmer that you need to try Mac OS on your Windows, inside your Windows. So you need to install some kind of software. This kind of software will allow you to be able to run a Mac OS inside it. So how you do that? You install a software. Um, I would try to recall the software I installed. I have one on one of on my laptops. So what I do is that, or what you can see that is you have to open that kind of software inside your laptop, and then inside it you will see something like different machines inside, and by clicking on each actually a Windows a screen of the new operating system will try to open or even boot up. Okay, so as if you are seeing how to say. Let me try to search. I think I have shared something like that with one of my students before. Let me see here. I would say so. I believe it typically looks like, yes, I think like that, yes. So if you look here, so this is your original, here will be your original Windows, this one. And once you start to open the virtual machine software that you already installed on your computer, and then you choose that you want to either install some software come with ability that you can just download a virtual machine for Linux, for example, or for Windows, old Windows software like Windows XP that doesn't run on the normal Windows. So this could be Windows 11, and you install the virtual machine, and he will tell you, okay, you can download an image from the internet, and this image is specifically for Windows XP, or you have to start installing whatever Windows or whatever operating systems that you would like to install inside the virtual machine. So it will open a screen inside your Windows like that. If it is a Linux, it will be also the same, or even the Mac OS. So you can do both at the same, you can even run one, two, three operating system inside that. So of course, if your machine or laptop is weak, so it means that that will slow down your operation, because inside here you have to, inside your virtual machine software, you have to decide how much of your RAM and your hard disk, oh sorry, we have to close and open,